probability is the measure of how likely an event is to occur. The set of all possibility outcomes is called the sample space. For equally likely outcomes, the theoretical probability of an event, denoted as P of E, is the ratio, or as you guys commonly know it, fraction, of the number of favorable outcomes to the number of outcomes possible. By favorable, that means it's the ones we want. All right, let's look at a first example of this. A jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? I always like to do my total first. Let's see, 32 plus 28. That means we have 60 marbles in the jar. And we want red ones, so that's 32. And because I'm terrible at fractions, I'm going to let my handy dandy calculator do the work. See, 32 divided by 60, hit enter, math, enter, enter, and I get 8/15. And I lied about fractions, so I'm going to do the rest of them in my head. Number two, see, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So, all your Vanna White people out there, I'd like to buy a vowel. Let's see, I have an E, an O, an A, an I, and an O. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total. 1, 2, 3, 4, 5 vowels. Look at that. It's already simplified. Number three, a day in the month of January is randomly selected. What is the probability of selecting a prime number? How many days in January? 31. Okay, my prime numbers. 1 is not prime. 2 is. 3. By the way, what's a prime number?
It can't be round anymore. That makes sense.
Its only factors is 1 times that number.
Yes.
Okay. Can't have any other factors. So, like the number 4 is 2 times 2, that is not prime. Yes. 5.
7.
7.
11.
11.
13. 17.
17. 19. 23. 29.
31.
And 31. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hey, look at that. We don't have to simplify this. You know why? Because 11 is a prime number. Number. Oh, we're not going to do number 4. No, 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 no,
Why not?
no, 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 no.
Two dice are.
No, we're not doing number 6 either.
Aw.
Although you guys can probably maybe get number 6. Number 5. What is the probability of drawing a heart or a club from a standard deck of cards. Hence, your little handy dandy little sheet I gave you, right? Let's see how many cards in a deck. 52. Good. Let's see how many hearts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Which means there's 13 clubs there too, right? So 13 plus 13, 26. Everybody knows what this is, right? 26 of 52 is a half. Yep. Okay, so that's simple events. Okay, one event. Then we get into the complement of an event, and the complement of an event. Where's my pen? Is the complement the probability of the event not happening? So the sum, since the sum of all probabilities in sample space is what's the most probability I can have? 100%, right? So if we're dealing with decimals, it's one. The probability of an event not happening, denoted as P of, that's a little, I believe it's a tilde sign. So probability of not the event is going to be 1 minus the probability of the event happening. Makes sense, right? Let's look at some examples of this. The probability that it will snow tomorrow. Now, the probability of snow that it'll snow on spring break, 100%, right? That's our luck. Okay, the probability of it snowing tomorrow is 7/20. What is the probability that it will not snow? So we want the opposite of that. So I'm going to take my 100% or 1 minus 7/20. Now, you guys probably used to putting this in your handy dandy calculators, and that's okay. I'm all right with that. 1 minus 7 divided by 20. Enter. Math, enter, enter. And I get 12/20. Did I do that right? Yeah. 13. I can't even read my own calculator. And I have brand new glasses too. That's horrible. Because 20 minus 7 is 13. 8. A month of the year is randomly selected. So what's my total number here? How many months in a year? What is the probability of getting a month that does not begin with the letter A? So let's 1 minus the probability of getting a month with A. April, August. And if you use my handy dandy cheat shortcut, 12 minus 2 is 10 twelfths. And reduce. 2 goes in the 10, 5. 2 goes in the 12, 6. Or you guys can use your handy dandy calculators. Number 9. If the spinner to the left is spun, find the probability that it lands on a number that is not prime. Well, instead of figuring out all the numbers that are not prime, we already listed all the numbers that are prime. So let's do 1 minus, let's see, there's 16 letters, right? Let's see, we have 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11, 13, and that's it. So 1 minus 1, 2, 3, 4, 5, 6. 16 minus 6 is 10 sixteenths. Divide by 2. 5 eighths. Okay, two die a roll, two dice. What is the probability of not getting doubles? Well, let's see. I'm going to do one minus the probability of getting doubles. Let's see. We got double ones, twos, threes, fours, fives, and sixes, right? Six out of, now I got six faces on each die. So six times six is 36. 36 minus six is 30. Divide each one by six. 5, 6. Piece of cake, right? So we needed to learn about simple events because I want to talk to you about independent and dependent variables. Okay. Independent variables. They're called compound events. Well, that's why I had to teach you simple events because this is going to be two of those simple events. When the outcome of one event does not affect the outcome of the other event, I have the probability of A and B. We are just going to multiply these probabilities. The probability of A times the probability of B. Now, dependent events is when the outcome of one event does affect the outcome of the other event. So we're still going to multiply the probability of A times the probability of B after A has occurred. Okay. So let's do some examples of independent probabilities first. A die is rolled 3 times. What is the probability of getting ones on each roll? One out of how many numbers on a die? 6, right? So my first roll is 1 out of 6. My second, so I'm going to multiply my probabilities here. Second roll, 1 out of 6. Third roll, 1 out of 6. And if I had my handy dandy little red cheat chart, I would know that that's 6 cubed, which is 216. All right, number 12. A coin is tossed. I either get heads or tails, right? 1 out of 2. What is the probability of getting tails? Then a day starting with the letter T. So I got days of the week, multiplied by days of the week. Start with T, Tuesdays and Thursdays. Just the two, right? And you guys can put it in your calculator and simplify it. But since I'm a studious student, do all my homework, I can do that in my head. Because the twos cancel out here, right? Okay, a bag contains 8 red crayons, 14 purple, 6 yellow, and I don't have a yellow, so I'm going to use the neon pink for my yellow, and 4 green. A crayon is selected, replaced, then another is selected. So we have independent events, right? Because you get the same opportunity the next pick. Okay, the first pick, probability of a purple, 14 out of 8, 22. 28, 32 total. Times probability of picking a yellow, 6 out of 32. And I believe Mr. D is going to use his handy dandy calculator on this one. 14 30 seconds times 6 30 seconds. Put our math enter, and I get 21 256. Okay, 15. The probability of two purples. See, 14 out of 32 times 14 out of 32, because we're throwing it back in there, right? So I have 14 divided by 32 squared. Math, enter. 49 256. There's some examples on independent. Let's do dependent using the same information. Okay. And we are not throwing that first cram back in there. Okay. That means the second one's dependent on the first one. So we're not replacing that cram. Probability of yellow is 6 out of 32 times the probability out of red, which is, see, we have 8 reds.
8 out of 31.
31. Very good. Awesome. Excellent. I could probably do this in my head, but 6 divided by 32. 8 divided by 32. Enter. Math, enter. 3/64. $19. Probability of two reds. While my first event, I have 8 out of 32. Second event, we know that we're going to go down to 31. How many reds on the second one? 7, right? Because we're keeping that crayon out. Let's see, 8 divided by 32 times 7 divided by 31. Enter. Math, enter. 7/24. Okay, 21. Card is drawn from a standard deck, not replaced. And another is drawn. What is the probability of choosing a heart, then a spade? Okay, I think I did this wrong in my last class because I read it wrong. Okay, we have 52 cards. And the probability of drawing a heart, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the probability of choosing a spade, well, I got 13. But we're keeping that heart out, so it should be 51. I think I did it right in my last class. Let's see, 13 divided by 52. 13 divided by 51. Enter. Math, enter. And I get 13 over 204. All right. So on your homework, on your homework. Let's see, I'm going to have you do the evens. And if you feel like you need more work, by all means, do the odds. All right, I got to give you some. Um, I'm going to have to give you some data here because my last class was throwing fits. Okay, it says a random two-digit number 10 through 99 is drawn. Find the probability of an odd number. There are 45 odd numbers between 10 and 99. See, what else was giving them a little trouble? I think that was it, right? Um, yep, you should be able to do the rest of them. Any questions? So do the evens. If you're having trouble, then do the odds.